Hi, this is sections 2.6. It's problem 38. And get your algebra brain working because you're going to need to help me here with this algebra. The calculus part of it's not going to be too bad, but the algebra. Oh my goodness. Okay, so it's asking us to take the second derivative, is what it's asking us to do with respect to x. So we're going to take the first derivative first. Remember, when you take the derivative, if I can solve for y, boy, that'd be great. But it's quadratic in y, and so I guess I technically could solve for y, but it would make a mess. And then taking the derivative of that mess. And so actually implicit differentiation is going to be easier than that. Every time you take the derivative of each piece, piece by piece. So you take the derivative of x squared, which is 2x, the derivative of this product, which means I'm going to have to use the product rule, and the derivative of y squared. I got my phone off. I'm in a group chat, so it's going to go crazy. And the derivative of this constant, and the derivative of a constant is 0. Okay, so and so I'm going to leave a little room because I have that product rule there. So u equals x, v equals y, u prime equals 1, v prime equals dy dx. So taking the derivative of the pieces, the derivative of this first piece is 2x. And the next piece, I have to use the product rule, which I've written all here. So that's going to be x, so plus x dy dx, and then plus y. And then the derivative of this piece is 2y dy dx equals 0. I almost said 3. But remember, you're taking the derivative of each piece, and the derivative of a constant is 0. And now I've got to solve for dy dx, and I'll have found the first derivative, and I was asked to find the second derivative. And so, well, it's possible to solve for dy dx, and I think that would make it very much more better, I think. And so that's what we're going to do. So we're going to keep all the dy dx's on this side. So that's x dy dx plus 2y dy dx. And then on the other side of the equation, we're going to put the other stuff. So it's going to be minus 2x and minus y on the other side. And then I'm going to factor out a dy dx. I'm going to divide by that piece. And I was thinking, oh, it was going to cancel, but it's not. I wish it did. If it did, that'd be lovely, but it's not going to. So I'm factoring out a dy dx, and then I want to solve for dy dx. So I'm going to put my finger on dy dx and divide by what I see. So I'm going to be dividing by that. And I was hopeful that this would reduce, but it's just not going to. And I could put the negative out in front there if you liked. I'm a little worried that if I get sloppy with my handwriting, then I'll mess it up. And so I think I won't. And so either way on that. I'm going to put a box around that. Okay. Then I have to take the second derivative, and well, you take the derivative of the pieces, and now there's only two pieces, and so the derivative of the first derivative is the second derivative, so that's lovely. And then in order to take the derivative of this over here, I would have to use the quotient rule. So here I go. So u equals minus 2x minus y, and v equals x plus 2y. U prime equals, the derivative of that is minus 2, and then dy dx, so minus dy dx. The derivative of y is dy dx. And then v prime here is 1 plus 2 dy dx. So I'm going to be using the quotient rule. So the derivative of this piece is the second derivative. And then the quotient rule is going to look like this. This times this. So this times this. Minus this times this. All divided by that squared. I'm starting to worry about the room. And then now all I have to do is simplify this. And once I make this look nicer, then I'll have the answer and I'll be done. And so that's what I said about the algebra. So there's a lot of different ways of going, and it's about half dozen each to the other. We'll have to decide what we think is best going here. But dy dx, right here, dy dx, well, dy dx is equal to this right here, right? So I would plug that in there. And this thing right here, right as it is, it's a binomial times a binomial. So should I plug in the dy dx right now, or should I FOIL it first? And then this right here is a binomial times a binomial. And should I plug in the dy dx right now, or should I FOIL it first? And I've done this problem. Well, I'm thinking I'm going to need this room up here. I'm going to go down here and then need to come back up here. But I've done this problem a lot of times, and I don't remember which way was the easiest way. I don't know that any of the ways were the easiest way. So right now I'm feeling like foiling it, and so that's what I'm going to do. And so if you're like, well, I felt like plugging it in, well, do that. So when I FOIL this, this is going to be negative 2 times x, negative 2x, and that's going to be minus 4y. And then on the inside there, ooh, that's going to make more of those, minus, I'm already maybe not wanting to do it, x dy dx, minus 2y dy dx. I think I'm going to see if it cleans up a little bit with what I have over there. And if it doesn't have some things cancel out, see, dy dx is, the denominator is x plus 2y. So that would cancel there when I multiplied it by that piece. Maybe that's what I want to do. And so already I've adjusted my algebra thinking here. This is going to be better. So I'm going to multiply the negative 2 just like I did. Negative 2x minus 4y. But instead, I'm going to write this as minus dy dx times x plus 2y, instead of distributing that part there. And the reason I'm doing that is dy dx has a denominator that's x plus 2y, and those will cancel, and that'll just leave me the numerator, which I'll have to make sure not to make a sign error. Okay, so I did that, and then over here, would you agree with me here? This negative here, I could multiply it through this one, and then all of these things would be positive. Would that be okay? A negative times a negative is a positive, a negative times a negative is a positive. That would turn this into an add. And so is it okay right now if I just make a note right here that I'm going to distribute that negative is what I'm going to do. I'm going to distribute that negative. So this is going to become plus, and then this is going to become positive 2x. So I'm positive here, positive here, positive here, and I'm even going to go and erase that there. Now, if you're thinking that I should keep multiplying that negative all the way through the second set of parentheses, The answer is no, I shouldn't. I'm multiplying essentially two things together. When you have these things and you're multiplying them together, 2 times 3 times 4, you would multiply the 2 times 3 together, get 6, and then later you would multiply it by the 4. You wouldn't multiply the 2 with the 4. And so when you tell me that, hey, that I should take that negative that was here and also run it through that parenthesis, that's what you're doing. You're telling me I should run here 2 times the 3 and 2 times the 4 when you just multiply 2 at a time. And so no, but that actually is very convenient, that it is just like that. So now I'm going to FOIL this together. So that is, and it's much easier because I don't have to worry about the negative. So that's 2x, so 2x times 1, 2x times 2 dy dx, so that's 4 dy dx, 4x dy dx. One little slip, you know, and I don't have somebody here to help me, someone to bail me out and say, wait a minute, plus y, and then plus 2y dy dx. And all divided by x plus 2y squared. So I was hoping for a bunch of like terms, and I have some, but a bunch I wouldn't say I have. I have minus 2x and positive 2x, so those are gone. I have minus 4y and plus 1y, which would make minus 3y. And so cleaning this up a little bit more before plugging in, I'm going to get minus 3y, and these are gone. They cancel out, right? And now I've just I handled this, so I'm going to put a little line through it. And then I have this dy dx, which I'm happy with because it's going to cancel. Remember, it's denominator. So that's going to work out okay there. Here, I was hoping that I could maybe put these together and have it turn out where this one canceled as well. And I was almost thinking that it did because of the 2y. I was thinking if I put these together and it would be 4x plus 2y dy dx. And I was thinking, oh, that would be great. But it's not. It's not 4x. It is 2y, but it's not 4. So okay, I just have to live with that situation. So okay, so I already have the minus 3y down here, and these other parts have the dy dx on them. So I'm going to write minus, and then I'm going to put in for dy dx this fraction here, minus 2x minus y over x plus 2y times x plus 2y plus 4x times that fraction, minus 2x minus y over x plus 2y plus 2y times that fraction, minus 2x minus y, x plus 2y, all divided by x plus 2y squared. So these cancel with one another, and those don't cancel with one another. I wonder if I want to multiply those together. Oh man, the algebra on this is, I remember, and it's making me sweat. Okay, so this negative will go through here and make those positive. So this is going to be the second derivative equals minus 3y, and when I distribute that negative, plus 2x plus y. I'm contemplating if I should multiply the 4x together or if I should just put the 4x up there in the numerator, and the same with the 2y there. I don't know. I'm going to multiply it. Anyone have my back? So this is going to be plus, and then in the numerator, when I multiply that 4x, is going to be 8x squared. Oh, but minus. Oh, man. And then here, I'm going to have minus 4xy all over x plus 2y plus, and then when I multiply that together, I'm going to get negative 4xy. And I know I could put that negative out in front, and I could have done that on that one too, but I'm worried I'm going to lose it. I'm worried I'm going to start thinking it only goes with part of it. So, so I have my reasons for not, but if your algebra is better than mine tonight, my algebra is kind of tired. My algebra's had enough today. Squared. So I'm almost done. No, I'm not. That was to make me feel better. I don't know if it made you feel better. I might have to go run and get some more paper though, because I don't know that I can fit it up there, but maybe I will. So now I have to, this is a complex fraction, and so that's not simplified. So I need to multiply by x plus 2y. So I need to multiply each one of these terms by x plus 2y, or the whole thing. This fraction by x plus 2y, which will just cancel the denominator. This fraction by x plus 2y, which will just cancel the denominator. And the denominator down there by x plus 2y will make 3 of them down there instead of 2 of them. So yeah, that's what I'm going to do. So here, yeah, why didn't I give us 2 pages? Well, I'm glad on the quiz that I accidentally got, not the quiz, the lab, I accidentally gave you another page. And right now I'm feeling like that was good. Equals minus 3y times, what was I multiplying again by? X plus 2y, the denominator. X plus 2y plus 2x times x plus 2y plus y times x plus 2y plus, will you guys allow me to say that the x plus 2y's canceled this out and just gives me that numerator? One person out there said yes, I could do that. Thank you, one person, for saying that. And the same here. I'm multiplying this by x plus 2y, so it cancels the denominator and just gives me the numerator. All divided by, I have to multiply this by x plus 2y. There was 2 of those, now there's 3 of them. Okay, so I am getting another piece of paper, and I fortunately have one that's not too embarrassing. Doesn't have anything written on it, in other words. Okay, because I just ran out of room, and I'm still cleaning up. And so when you see how much this cleans up and simplifies up, you'll be amazed. So here we go. We're going to distribute, so hopefully I won't lose it. Minus 3xy minus 6y squared plus 2x squared plus 4xy plus xy plus 2y squared minus 8x squared minus 4xy minus 4xy minus 2y squared, all divided by that denominator. So the calculus actually was pretty easy. We've been done with the calculus for a while, and but now we're cleaning it up and making it look nicer so that it's more presentable. And so away we work. And I got this now on this paper, so I can kind of move this on to here. Maybe I'll even just set this out to the side. And so let's see here. Like terms, I'm going to combine them. So I'm going to write my x squares first, just because that would be in descending order. And if anything cleaned up too nicely, then I would have it. So right here I have 2x squared minus 8x squared, which I think makes minus 6x squared. So I have all the x squares out of the way. I'm just going to make a light line through them. And I want to put next, I want to put x to the first. So I have minus 3xy plus 4xy. That's 1xy. Another 1xy makes 2xy. Minus 4xy is negative 2xy. That's minus 6xy. So I got all these xy's. Then on the y squareds, I didn't get that one, but I did count it. Minus 6y squared plus 2y squared minus 2y squared, so minus 6y squared. All divided by that thing cubed, which it's looking better. Now this is the amazing part, and this almost always happens in these problems where you take the second derivative and you use implicit differentiation. It doesn't happen every single time, but it almost always happens. It certainly happens on the problem you'll be working on as well, and that is this. You might think you're all done, but I don't know if you notice something. If I factored out a negative 6 here, that I would have what I started with, which is equal to 3. So I am going to do that. So this is minus 6. This is x squared plus xy plus y squared, all divided by that same darn thing in the denominator to the third. And I hope you're noticing that now I have that. And that is equal to 3. So I can substitute x squared plus xy plus y squared with 3. And then I will have simplified this thing pretty well. And you have to admit it looks pretty good. Minus 6 times 3, which is negative 18, over x plus 2y cubed. So this is negative 18 over x plus 2y cubed is that second derivative. Anyway, so that's kind of that story, there. Lots of different ways we could have gone. You know, we could have put that that second derivative in here, and then tried foiling it. Maybe I could have combined all the dy dx's, and maybe that would have turned out nice, and maybe it would have been even better. I'm not sure, because see here I have x plus 2y of that. Actually, it's minus x and minus 2y. And then here I had a plus 2y. Ooh, and that would have canceled with that. And then this would have been, so that would have been maybe some less of them. I don't know. There's some different ways you could have gone. I think I could have, in other words, factored a 2y out of all dy dx out of all of these and put those together. Maybe that would have turned out, maybe that would have turned out a little bit nicer. I don't know. No matter what, I was going to work pretty hard on that algebra. Okay, so I'm done with this video and stop.